Okay, Algebra 1, we are moving on to a new chapter, graphing, solving linear systems by graphing. Now, we've talked about graphing lines before, and this is not any different. So this is not new material at all. This is all 100% recycled material. None of it's actually new. It's just what we're doing is we're taking things that we have learned and sort of solving new problems with them, but the math itself is not new. So don't be too intimidated by it, is what I'm trying to say. Okay, so first, let's talk about what a system of linear equations is, because that word can seem kind of daunting. A system? Math? What is that even talking about? Right? So all it really is essentially if you take two lines, and remember, lines could represent lots of things. We just got done talking about scatter plots and how those lines create trends of certain variables. As one thing goes up, another goes up, right? So there's lines about a lot of stuff. So a system is when you take two lines and you find out essentially where they meet, what point they have in common, the place where they cross, right? So let's talk about that first, and then we'll get into actually solving them. But first, let's talk about just more about what a system is, what it looks like, and kind of what we're getting into. So here, looking graph A. Now, graph A, you've got it looks like a lot of lines, to be honest with you, but keep in mind, I'm going to put in red here the lines that it's referring to. The lines in black that I'm going to leave in black are just the XY axis. So these lines in red are the lines that we're really talking about. The other lines, this is just the X axis and the Y axis. So don't mind that. Okay, but the two red lines is what we're referring to. Okay, so describe the relationship between the two lines. Now, I'm not going to write this down just to save time, but I'll tell you, and you guys could write it down. The relationship between the two lines is that they are different lines, but they do only meet in one place. They only have one point of intersection, and let's use I guess a highlighter here, right, to emphasize it. Here, right, where they cross, that point of intersection is there's just one, right? And you gotta tell yourself, you gotta think to yourself like, well, there's only one intersection point because, well, frankly, there we go. Frankly, how could two straight lines, cross more than once? That's a good question. They really don't, right? If you have two straight lines, they cross in just one place, right there, right? So that is what our solution would be. Our solution is this one point that the two lines have in common, because that one point right there is on both lines, and it's the only point on the entire grid where both lines meet, right? So that's the solution, so to speak. Okay. So what other questions do we have? Okay. What do you know about every point on the graph of a linear equation? Well, we know that all the points on the lines are different, except for that one point that I've mentioned here where they cross that they have in common. That one point is on both lines, but every other point on those lines is different. How many solutions does a system have? A system of two equations have if the graphs of the two equations intersect exactly one point? And the answer is they only have one solution, because the solution is where they cross, the point at which they cross. Describe the relationship between the two lines in graph B. Now, here's the thing about graph B, and it's kind of doesn't really give you all the information. But there are two lines here. Let me tell you what I'm talking about. So you still have your X and Y axis. We're not talking about these lines here, the X and Y axis. We're talking about this line. Now, to you, it looks like one line. And to me, it looks like one line because essentially it is one line. But what they're not telling you here is that, in fact, there's actually a second line sitting directly on top of it. The two lines are essentially overlapping each other, which is why it looks like one line, because it's one line directly on top of another. So these two lines are the exact same line. That's what we're trying to say. The two lines are exactly the same line. Okay, how many solutions does the system have of two equations if the graphs of the two equations intersect at infinitely many points? Well, keep in mind, remember, a solution to a system, okay, a solution to a system is the point where the two lines cross. The point where the two lines cross, where they meet. Now, in this problem, those two lines cross at literally every single point, because every single point on one line is exactly the same point on the other line. So they have every single one of these points in common, meaning they have infinitely many points in common, or infinitely many solutions. Now, don't confuse infinity with every point, because it's only the points that are on this line. You know, points like 0, 0 here, or anything else, all these points, these are not solutions. They're still wrong. But there are infinitely many points on this line, which is why we say infinitely many solutions. Because a line is essentially just made up of infinitely many points just all put together, right? That's what a line is. So that's why we say infinitely many solutions, because on that line there's infinitely many points. But it doesn't mean every point, because obviously there's points all the way over here on our grid that are not on the lines, and they are not the solution. And then the last one, of course, the graph C. Now you can clearly see these two lines, they're not trying to hide from you. These two lines are parallel lines, meaning that these two lines, as you can kind of tell, are never going to cross each other. They're never going to intersect. Well, remember, the solution is where the lines meet, where they cross, the points they intersect. And if these two lines do not ever intersect, then these two lines do not have any solutions. Remember, solutions, again, are points where the lines cross. These lines don't cross, so they have no solutions. So we would say no solutions for graphs like that. All right, so now let's get into actually the math, okay? So that's just a quick explanation of what systems are. It's simply just two lines, you know? It could be kind of weird at first, but it's just two lines, and your goal is to just figure out where they cross. So look at this graph right now, and you can clearly see your two lines. You got here and here, and there's only one place that both those lines have in common. Only one place where both lines cross, and that's right here at the point 1, 4, right? So our solution is the point 1, 4. So that's another thing to keep in mind, okay, as we move forward. The answers to all of these is a point, an ordered pair. So your answer should be an X, Y ordered pair, like 1, 4, for example. Your answer is not going to be just one number. Your answer is going to be two numbers, okay? A point, an X, Y ordered pair. So don't ever say the answer is like 3, because that doesn't make any sense. That's not a point. The solution is a point, the point where the lines cross. That is your answer for these, okay? All right, now let's see how they graphed this real quick. So here's what they did. They had these two equations, and they had to graph it. Okay. Now, for us, we're very familiar with graphing y equals mx plus b, slope-intercept form. We're going to see that a lot. We're going to practice with that a lot. It's going to be good practice. But they've done it they don't have slope-intercept form here, so they've gone through a different process. And I'm going to show you that process in a second. But quickly, what I actually want to do, if I can find a good example, let me scroll down. This is going to take a second to kind of have to zoom out. All right. I want to go back. I want to go down to the homework questions and see if they have any particular questions that we can graph. Yeah, for example, like number 5. Okay. Number 5 in the homework. This is, what we're used to, slope-intercept form. For the first line here, we can see the y-intercept is -4. Remember, we've talked about this not too long ago when we were graphing our inequalities. Y-intercept is -4, so that line starts at -4 on our y-axis, which is that up and down axis. So we have our first point at -4. And then our slope is 4/3. So remember, the top number tells you to go up or down. If it's positive, we'll go up. If we have a negative, we go down. But the bottom number tells us how far right to go. So in this case, it's 3. So what this tells us to do is go up 4, since it's a positive 4, and then right 3. So we count up 4, 1, 2, 3, 4, and right 1, 2, 3. In fact, so if you're wondering why I hate these graphs so much, the fact that they've used these graphs are going by 2 again, if you notice. So this is actually -2, this is -3, this would be -1, and that's where 0 is. This would be 1, 2, and 3. 1, 2, and 3. So when you go up 4, you're kind of counting these half squares. Now, in all honesty, though, you could still count the grid and it would still work. You're just kind of doubling what you're doing. So you can still kind of count up 4 squares, up 1, 2, 3, 4 squares, and over 1, 2, 3 squares. That still gets you to the same place that you would eventually get to anyway. So that's probably just better if we just do that. Okay, but anyway, that's where your line goes. Remember, there's no like dotted line or solid line or shade below or above kind of thing here like we had with the inequalities. This is just graphing a line. So we graph our line. Remember, the other line, y equals 4, is just go to the y-axis, go to 4, and then draw a line directly through it, straight through it, right? No up or down slope, just straight through 4. So that line is here, okay? So we've graphed these lines before. This is not new graphing. This is the same graphing. You know, the y-intercept for the first one, the y-intercept's at -4, and then our slope was up 4/3. We've done that a million times, right? And then the second one we've had some practice with recently as well. It's just y equals 4, meaning you go to the y-axis, you find 4, you put that point, and then just draw the line straight through it, which we did. So our answer to this system, again, is, of course, where the two lines cross. That's the only new thing that we're doing. We've graphed these lines a million times, but now the question is, where do the lines cross? And in this case, they cross at the point 6, 4. For the y-axis, it's at 4. So 6, 4 is the solution. Now, let me go back and kind of discuss with you what they're doing in that problem previously, this problem up here. So remember, this is not slope-intercept form, okay? But here's how you can graph it. Essentially, you can find the x-intercept and y-intercept for each graph. And how you do that is it's really simple. In all honesty, we just haven't practiced it enough. But if we practice it a lot, you'll see it's really simple. To find the x-intercept, just solve the equation 2x equals 6. Ignore the y. 2x equals 6. So if you divide by 2, you would solve this equation and get x equals 3, the x-intercept as 3. If you want the y-intercept, then you just solve the equation y equals 6 and ignore the 2x. And in this case, y equals 6 is already solved. There is nothing else to do. So the y-intercept is just simply that 6. It's very simple, but it's kind of weird just because we haven't practiced it a whole lot. We've done it a little bit though, right? And on the second graph, if you want to find the x-intercept, then you just solve -x equals 3. -x equals 3, and ignore that y. In this case, you do have to remember to divide by -1 because it is a -1x. But other than that, you know, it's pretty simple. You have 3 divided by -1, which is -3. So the x-intercept is -3. And then, of course, if you want the y-intercept, then you just solve the equation y equals 3 and ignore the x. And just like before, y equals 3 is already solved, so there's no more work to be done here. The y-intercept is 3. So that's all it takes to do those. And so when you go and graph it, you don't have to worry about a slope or anything. You just have to graph the intercepts. So for this one, x-intercept at 3, you would put the point here at x being 3. Let me go ahead and erase my original lines. X equals 3, you'd put that point there. And then the y-intercept at 6, you'd put that point there, the y-intercept at 6, and you draw a line through it, okay? It's very important, though, that you make your line as straight as possible because you're going to know we're going to cross eventually here in the middle. So if your line is not straight as possible, it's going to be hard to tell where those lines cross. So make sure your line is as straight as possible. And the other line, let me do it in blue, just so it stands out a little differently. Remember, x-intercept was -3, so you go to the x-axis, you go to -3, and the y-intercept was +3, so you go to the y-axis, you plant +3, and then you just graph a line through it. Remember to try to make it as straight as possible. You don't need any slopes, nothing like that. You just have to make those 2 points on the x-axis and the y-axis, and then just connect them with a line. That's all you have to do to make your line. Just again, like I said, make it straight, okay? Because it's going to be very crucial in determining our solution. So just keep that in mind. It's a very simple trick. It helps you from having to do more work than you need to. And let me practice that before I work this second example out. Let's practice this a little bit. Let me make some equations up, and let's just practice that trick a little bit. So let's say I have 3x plus 4y equal to 12. And also, let's say I've got the equation negative 2x plus 7y equals 14. So if I want to find the x-intercept of, let's talk about the first equation here, and then we'll get to the second one later. Okay, but let's talk about this first equation. If I want to find the x-intercept, then I'm just solving the equation 3x equals 12. And then again, like I said, ignore the y. So 3x equals 12. You solve that. Simple enough. You divide by 3, and then you see x is equal to 12 divided by 3, which is 4. So we found the x-intercept is 4. If you want to find the y-intercept, like I said, you just solve the equation 4y equals 12 and ignore the x. So you're just looking at one part of the equation at the time. 4y equals 12. So you divide by the 4, in this case, to solve it, and you have y is equal to 3. And that's all it is. That's a simple trick, right? Let's try it with the second equation as well. The second equation, we have just for x, we have negative 2x equals 14. Negative 2x equals 14, and we can solve that. Divide by that negative 2. We have x equal to negative 7. And then the other part of this, we have, for the y, we have 7y equals 14. So 7y equals 14. So divide by 7 to solve for y, we get y is equal to 2. So that's how you can get the x and y intercepts, okay? It's a simple, really, really simple shortcut. It's going to save you a lot of time, makes this process a bit easier. So let's try it here. Now, I'm going to not do it on this one, but I will do it on the second one. You'll notice probably the reason why. This one's already in slope-intercept form, which we already know how to graph. We know that this one has the y-intercept at negative 2, so we'll put our point at negative 2, and our slope is 2. That means go up 2. But remember, anytime it's a positive number, you always, after you go up 2, you still have to go to the right 1. So remember to go up 2, but right 1. A lot of times people forget that when they see their slope just being 2, they think up 2, they put a point at up 2, and they just keep going up 2, and they make a straight line like that. That's not a slope if it has a straight line. So you have to remember, after you go up 2, to go over 1. Okay? And so we do that again, up 2 and over 1, up 2 and over 1, right? And you can make your line. Okay, it's very important that you make this, again, as full as possible and as straight as possible. You don't want to take any liberties here. Oops.
Could you try again?
Sorry. Siri thinks she's talking to me. All right. So we can graph that line easily. We don't need to do the x-intercept, y-intercept thing. It was simple enough. Okay. So now let's look at the second equation. Second equation is 3y plus 6x equals 18. So remember, just find the intercepts in this one because this is not slope-intercept form, right? So let's just solve 3y equals 18. 3y equals 18. You solve that, so divide by 3 to solve it, and we have y is equal to 6. So we have the y-intercept is 6. If you want to find the x-intercept, then just solve 6x equals 18. 6x equals 18. So divide by 6, and we have x equal to 3. So our x-intercept is 3. So now just plot those 2 points. The x-intercept at 3, which is here, and the y-intercept at 6, which is here, and do your best to make as straight a line as you possibly can through them. A ruler usually helps, okay? For me, I don't have that because this is a screen. All right? Don't worry about this third point thing. That's not really important for what we're trying to do. But there you go. You've got your lines graphed. Now, all you have to do is just look at where they cross. Find out where they cross. They cross clearly here at this point, which is at 2, 2. So your answer is the point 2, 2. Now the last part is just checking your answer. If you're curious to know if you did it correctly, then you can plot the x and the y into the equations, and you can see if they fit. So for example, let's plug the 2 in for the y here and the 2 in for the x here, and we'll see what happens. In this case, we end up with 2 times 2, which is 4. So that would become 4 minus 2, and 4 minus 2 is 2. And that, of course, equals 2. So 2 equals 2, that checks out. If we go back to the original of here, this 3y, so remember, the y is 2, because our answer, the y value is 2, plus 6 times 2, because you remember the x value was also 2. All right, so that was the y, that was the x, equals 18. Let's see what we get. 3 times 2 is 6, and 6 times 2 is 12, and 6 plus 12 is equal to 18, right? So you can see, plugging in the points, it fits. It all works out, okay? So I think that's where I'll end it. I'll stop there today. You'll probably have some homework over these. But that's kind of the idea. Remember, slope-intercept form is pretty straightforward. And then just use the shortcut as well. Use the shortcut. It helps out a lot. There's really nothing else new here. I think that's pretty much it for the most part. So we'll see you guys in class, and good luck with the rest of this. All right? Bye.